Okay, ready to go? Okay. I was tasked with the task of putting out a little presentation on a little project that we did over the, I guess it was the spring semester here in my college. And it's dialed off a little bit off the Barbie house, but we put a little bit different spin on it, of course. Make it around myself. A little background on myself there. You can see my name. I've been a licensed engineer for all my career. Came from the industry side of it, or professional side. Lead accredited professional for 24 plus years. Certified energy manager for probably another 20 of that. And commissioning authority. Little inside joke. For longer than that, probably, I think it was like 25 years or so. And GBE, which is the Green Building Engineer. So we started with a free castle because we're looking for a platform to put this on. And we were actually working for a dollhouse. That's what we really started out with. And of course, our funding was, either we spent our own personal money for it, or we got something for free. Well, I chose the free side of it. So we actually went on junk for free or whatever the site was, and lo and behold, somebody had a throwaway castle. So that's what it started with. Ended up looking like that after we got going on it. So I'll get into a little bit more detail. We started with the old contemporary control panel, and we used the 20 IOs, figuring, plenty of space,
Where were you going to use this?
What?
Where are you using this?
On the castle here, the
In the lab itself? In your lab?
Oh, where I picked up the controller?
High school. What are you using?
Oh, where we're using the castle? Oh, okay, that's a good question. We started doing some outreach out to the high schools and bringing it down, and we needed something to kind of demonstrate, building automation. And that's what the whole purpose of the Barbie house was, to bring that into a lower level of, understanding in the community. So this is what the whole purpose of this device was. So we could carry it out in the community world and present it as a demonstration of building automation. So we started out with a controller because that's what, we want to base things off of. And 20 IO was probably good. Well, I found out after the students got involved, that grew, and I'm stretched on the 20 IOs here, and almost should have went to the 22, really, controller. So, of course, we have an energy program, Renewable Energy also. We can't let them down. So we have, on the castle, renewable energy, wind and solar. So I have a little solar panel up here. We got out of the junk pile. We went over to the solar group, and they said, yeah, this one doesn't seem to work anymore. I said, hey, I'll take that. We strapped it on the top of the roof. Found out that it does generate a little bit of voltage. That's all I needed. Throw it in the I/O into the good old controller there, and use it as a switch. So as long as it produces a little bit of voltage, I got an input. Bam, that's a switch. Put the output, and we turn on these Christmas lights that we pulled out of the other junk pile. Has LED lights, and it turns it on. It emulates pretty much what a inverter or a converter, basically, or inverter does in the solar side, where it takes enough of solar energy until it finally triggers to go. A little wind turbine up there, and that works on the same principle. As we get a can of air, we blow against that, generates a little bit of power, a little bit of energy, electricity, and switches on the lights. And then we have the little control program there showing to the acquisitive overachievers that we go out there and want to know how it works. There's the block diagram. Here's our constant voltage. Here's our either one, fires up, boom, and the lights come on over there. simple input output. Okay. Well, that carries the renewable energy boys. That's great. We don't want to give too many people out. We don't want too many going to the renewable energy. It takes away from the BAS, doesn't it? Okay, so we got to get the BAS in his thing. So the next step is we're going to deal with temperature. So one of the students brought in these characters. I don't know where they're from. That's my dying generation. But anyway, this guy's name is Harry. So we connected Harry with a little sensor, and we use him as space temperature Harry. For a little sequence, simple sequence. When the applicant or whatever we were sending it to can come up there, warm up their hand, touch the sensor, and when temperature rises, we start a fan. When it decreases, we start the HVAC unit, which really isn't an HVAC unit. It's really just a electric furnace, but most people know it by HVAC. So that works really great. Then we get into Set Point Steve. Set Point Steve introduces the process of...
Can I ask a question? What's your furnace? Is it...
Oh, we'll get there.
Okay.
We'll get there. Don't hold. Well, that's a good question, Paul. So we got Set Point Steve. And now we start introducing the idea of we can change the set point that affects the outcome. There's our furnace.
I love it.
Soup can. Got out of the trash can. Knocked a little bit of tin together. Any good engineer can do. Or anybody else. Knocked a little tin. And as you can see, you can see that little center we took in, and we had to have supply air temperature. So we have a little furnace there. Close the fan, furnace the fan. And we got sensing the supply temperature. I'll show you why that we need the supply temperature later. So again, spare parts basically didn't really cost us anything other than a little blood and, cutting metal and a couple other things and whatever. But that's all learning at the moment. So the student said, we got a castle. Gotta have a drawbridge, don't we? And the drawbridge has to be operable, doesn't it? I mean, what's a castle without a drawbridge? So we went over to the CAD guys. The CAD guys have a 3D printer. We said, here's what we want. This is a drawbridge. This is size and stuff. They drew it up, printed it out, got a 3D printout. Boom. We had our drawbridge. What did it cost us? Okay. And that is Thor, I think it is. He gets out. We'll see that a little later. Okay. The soup can furnace. Little light, specially picked, because it gets real hot. We didn't use one of those LED guys. No. We wanted that thermal side. And hopefully it works, yes. And if you watch this, and unfortunately the video doesn't show exactly when you see it real life, the fan is varying its speed. Okay? So that imposes, I have a little, it's not a VFD because I don't change the frequency, but I change the voltage, so it's a VVD. Yeah. And the purpose of that is, when the fan slows down and almost stops, well, actually it does stop, we're transferring that heat energy from that lamp. When you decrease the CFM, what does the temperature do? Goes up. What's that supply air sensor doing? Sensing an increase in temperature. Okay. So what happens? Now, Count how many senses I got done so far. I got visual. I got feel. You touch the thing. I got smell. Good. Hey, see the smoke. Hey, smell the smoke. I didn't realize this, but you can buy scented smoke. It smells like different smells, like chocolate, hot chocolate, wintergreen, all kind of things. Yeah, I know, it's amazing. I didn't even know that, but I found out. Yeah. In the wintertime we use hot chocolate because it. So people come into, like we were doing in a conference center or whatever. People start smelling hot coffee, chocolate. They come over to our, where's this stuff? Like, coming from that smoke there, you know. See it? And we generate a lot of smoke. A lot of smoke. Okay. So, oh no, there's smoke. We gotta save the castle. So, what happens in a building when you have smoke? You must have a fire. What? Well, we didn't get that. That would have been. That wasn't suggested by. I mean, there's limitations here. You know.
Did he use it?
No, there's limitations.
Be able to
Okay.
use-
There's definitely limitations, but you can see it smoking. So, we have the drawbridge comes down for egress. And it's a little hard to see in this video, but you can see these flashing lights. Yeah, give me back. Let me go through this. There. You can see these flashing lights? There are strobes. So we have a fire alarm system. And with a horn, but unfortunately the audio isn't on this slide video. So we have the fan operating. It starts malfunctioning. Smoke comes out of the diffusers. Diffusers, well, I think I have a sequence here. Exceeds the high limit. Sets off the fire alarm. Strobes and horn goes off. And of course, our draw bridge drops for the occupants to get out. Program got a little more complicated than the one I just showed you in the beginning here. and that's kind of just a subset of it too. It got a little complicated there, but that's for the overachiever so they can see it. Okay, so anyway, that's basically the whole box there. What do we have? Well, I always judge a lot of these projects on how much the students learn and how much fun they had. Well, they definitely had fun. I mean, they look forward to this. They basically came in extra time. They were everywhere on this thing. And coming up with some creative ideas. I mean, when originally you didn't have smoke. And when student says, we have to have that. I'm like, well, where can I get that? And then one student says, well, I have an old train engine that smoked, but it doesn't work anymore. Bring her in. We'll take it apart and we'll put it in here. So pretty much the whole castle, other than the controller, which we got basically had in the lab anyway, didn't cost us anything but time. So. Any questions?
And did you develop it as part of a course?
What?
Did you develop it as part of a class?
We've developed it as an outreach, device, basic example, go out in the outreach area to do that. But I just dovetailed it into the course. I had a control course going on at the same time, and made it a, we would do our normal course material, and then at the end of the class, that last half hour of the class, they got to work on this, and I just kept just kept feeding them, you know. It's
Cool.
you know, once you get them started, you know, it's like you got to stand all the way, you know. So.
That's fantastic, man.
What?
I love it.
Yeah.
How does it work as a recruitment tool?
Well, it's a little early to find that out. Well, I mean, we only had it this spring here. It's been working out quite well as far as you know, interest in the, you know, bringing people in. Any student coming through, or any student that looks in the future, what, you know, get a kind of good understanding. We really kind of made it for that junior high, middle school area range to get an understanding. But I think it's going to work out very well. And you might have noticed that there's a lot of Bitmojis in that thing, a little bit of somebody that looked like me maybe at one time. I like to put those in my course material. You know, the kids relate to that, and every once in a while I'll put a wild one in there. So I know you guys, you know, get kind of bored with lots of graphs and plots and that kind of stuff that we had probably. So I thought, hey, I'll saw what we were going. I'm kind of on the end of the thing, so we need to cheer this guy up. So,
Gary?
So what did you use for the actual physical mechanism to lower and raise the drawbridge?
that's a good one. A little servo motor. If you're ever in RC planes, RC models, RC cars, you know, the little servos, you can get, you know, you can, basically I have a couple leftover or whatever, but you can get any size servo, and you can actually probably see it.
I'm getting you there.
Yeah, there. See it there? Okay. And you can get a little board that basically takes it and allows you to adjust the stroke, basically, you know, what range of movement, start and stop, or anything like that. That's all that is. In the control program, it's just a digital out. You know, two position.
Right. Jim, do you think we could get a list of all the parts?
Yeah, but you have to have a surplus of trash. I mean, I had this box of you know, broken whatevers from previous instructors and whatever, and I was just like, oh, what can we use this for, guys? So, hey, well, hey.
Well, actually, no, I had an even better question than Larry. What are you going to ship?
Where am I going? What?
So,
Yeah. Oh, we also built you know, we have to take these around out in the community and stuff like that. So, you know, a lot of moving parts and whatever. So we built a box that goes down over, and then 2 pins actually go through the bottom of the box that just slide in, and then you can carry it. Like
Robotic? Yeah. Do you think it would make sense to have it as modules, maybe where you can just put it together as you reach to destination instead of just have it?
Well, the box works pretty well. You know, you put handles on the top, and you know, it just drops down. 2 pins on the bottom. It lifts right up.
Have it as a Lego, maybe just divide it into sections and just plug it in at the side.
You can put it on a hand cart and go. You know. Not too bad. It's not that heavy anyway.
Yeah, okay.
And the frame is it's that castle thing.
Yeah. Mhm.
What?
You wouldn't want to cut it into pieces.
Yeah. Well, yeah. It's just press board. So I don't know if it'll go back together again. We drilled so many holes in this thing. I was wondering about the structural integrity in the first place. But you know, they do make you know, chemical adhesive like glue that fixes holes and stuff like that.
were these second-year students?
What?
Put this together, were these sort of second-year students in the energy management program?
And,
They're in the BAS program.
yeah. What do you mean?
Oh, well, my understanding of the curriculum is you have energy management and the BAS track within the energy management degree program, right?
each program's a separate, we have a separate BAS, separate energy management, and separate solar or renewable, yeah. Yeah. But not the students, take some common courses between the two and all that kind of stuff like that. This advanced controls was basically a combination with the energy management and the BAS were in that same course. That's what.
Nice ferrule work,
Next slide.
ferrule work. The ferrules on your controller, really nice.
Yeah.
Looks really nice. Any other questions from Jim?
Yeah.
Yeah.
Any other questions? Is this good count as my presentation too for the tomorrow? For the guy, he got his done.
He's leaving, by the way.